Okay, question 30. Okay, let me capture this one again. Okay, I think my space may be okay. Let me just try again. Okay, it's a 2 little space. Okay, let me screenshot a bigger one. Not enough space for me to put in what I want. Oops, sorry, I clicked the wrong thing. Where is my question? Okay, this is my question. Okay, let me copy this one. Okay, not enough space for me to work. Okay, I have a common cathode 7 segment. Okay, so I think for this question, okay, you have no choice but to know. Okay, the fire alarm is turned on. I think there's some repair work going on. Okay, so let me just stop for a while. Okay, let me continue. Okay, you have a common cathode 7 segment. Okay, so what you need to know first, LED consists of one short leg and one long leg. The short one is negative, long one is positive. Short one is called anode, okay, and long one is cathode. Okay, and then the current can only go from oops, let me rewind. Okay, I made a mistake here. Okay, let me rewind. Okay, the long leg is anode. Okay, the short leg is cathode. Okay, cathode. Okay, so the current can only go from anode to cathode this way. Okay, I label them wrongly. Okay, so in terms of the real LED, okay, is like that. This is the anode, this is the cathode, and current can only go this way. Okay, now the question say common cathode, meaning that I have a few LED, the cathode are all connected together. So you have to draw this way. Okay, this is the cathode. Okay, another LED. Okay, cathode. Some more. Okay, LED, cathode. Like that, and all the cathode connected together. Okay, so this is called common cathode. Okay, and of course the cathodes have to be connected to ground. And I should output a 1 to turn this one on. Okay, I output a 0. Okay, there will be no current. Okay, this is 1. Then it will turn on. Okay, so 1 to turn on. Okay, first thing. So I connected to port B. So there's a port B here, and I have 7 segment plus decimal point. Okay, so segment A to PB0, segment B to PB1, and so on. Decimal point, the last digit. Okay, the last LED connected to PB7. Now, which of the following lines will result in 7? Okay, I want to show, 7 segment is actually X segment like that, with the decimal point. Decimal point. So I want to show 7. I should light up segment A, segment B, and segment C. Okay, so which one will result in 7? Okay, so let's look at this one. First one, I need a port in cannot work. I need a port out. Okay, the port out. Okay, I'm using port B. Okay, so all these 3 are okay. I need to have a mask here to say that I'm using the last. Okay, FF is 1111 1111. Okay, I need to have FF to say I'm using all the pins. PB. Okay, according to the question, I'm using all the pin PB0 to PB7. Okay, so I need to have FF. Okay, this is for turning on PB0, PB1, 2, 3, 4, 5, 6, 7. PB7. Okay, so this one cannot already. Okay, this one 7 not enough, only 3 pin use. Okay, I should be using this one. Okay, FF. Okay, FF. Okay, and then I segment 1. Okay, which is the variable name here. I should output 7. Why 7? Okay, it so happened that 7, if you write in binary, oops. Okay, if you write it, okay, I'm at the edge of my tablet. Binary, it will be 0, 0, 0, 0, 0, 1, 1, 1. Okay, 7 happen to be this one, and this one happen to be, okay, you put 1, 1, 1. Okay, turn on this 3, you show 7. Okay, the rest are the 5, 0. Okay, this one will be, okay, the 5, 0. Okay, so this is the answer. Okay. Okay. Okay, but there's one simple thing I need to, actually not simple thing. I'm going to highlight some strange thing. Okay, you'll be quite surprised by this one. Okay, let me just turn the pen to, okay, this one is also the answer. Okay, why is this one the answer? Okay, you look at this 7. Okay, this one say I will only be using 1, 1, 1. I'm only using the last 3 pin. Okay, the last 3 pin. This is PB0. Okay, this is PB2. Okay, this one. Okay, PB012. Okay, I turn on this one and I output this pattern, which will be, okay, this pattern. Okay, let me show. Is 0, 0, 0, 0. 1, 1, 1, 1. Okay, you can see that the same 3, 1 will be sent to the 3 pins which are set as output. So it will also be showing 7. Okay, but this is a bit weird answer. Okay, it's a bit of a weird answer. So it's acceptable also. Okay, CD can be answered. Okay, but this is a very weird one. Okay, you can only show 7. Let's say you want to show some other number. Okay, for example, those are numbers that involve the segments here. Okay, you will not be able to do so. Okay, so I don't think it's a good choice, but it can work in this case. C and D. Okay. Okay, so let's read this one. A to D. If the reading is more than 0.8, LED at port C turn on. Okay, what is the missing line here? Okay, so I have included some library. I have a analog input at PA0. Okay, it's connected to a variable resistor. I have a LED bar as a port out. Okay, the variable is voltage data. Okay, so I initially display off. Okay, then I set the reference voltage 3.3 volt. Okay, I'm going to loop here while through, and then this is the end of main. So what I do is variable resistor is the name of the pin. Okay, PA0. So I do a dot read. Okay, you remember dot read will give you a value from 0 to 1. Okay, it's scaling the input 0 to 3.3 volt to a value that is in the range 0 to 1. Okay, so all I need to do is if more than 0.8 turn on. Okay, so actually the answer is very simple. Okay, I just need to have more than 0.8. Okay, turn on. Okay, this one less than, not the answer. Okay, so which one is the answer? C or D? Okay, you have to see. I want to turn on PC0. Okay, meaning this one should be the answer. Okay, PC0. Okay. Okay, this is quite a straightforward question. C is the answer. Okay, next one. This one will require some calculation. Okay, let me just capture this one. Okay, see whether enough space to. Oh, okay. Let me. Okay, capture again. I need some space to work out the answer. Although it's not a very complicated equation. Okay, so let me use a pen to work out the answer for you. Okay, you know that for this where's my pen? Okay, A to D conversion. Okay, A to D conversion. you have V reference minus and plus 0 to 3.3 volt. Okay, so here is 0, here is 3.3 volt. Okay, this is your analog input. Okay, and this is your digital output. Okay, we have used this one in the lab also. I mean, during the tutorial, it's a straight line conversion. Okay, so the highest point will be converted to is a STM32, so 12 bit. Okay, so if you put 1111 12 bit is 4095. Okay, the lowest end of course is 12 bit of 0, so it's a 0. Okay, so now the question say my input is 2.2 volt, so it's somewhere here, 2.2 volt. So what is the result of the conversion? Okay, so you know that it's just this one over this one multiplied by this one. Okay, so the answer is 2.2 over 3.3 times 4095. Okay, you need to use your calculator to work out the answer. I think this is quite straightforward. Okay, let me use my calculator. Okay, it's 2/3 times 4095, so 2730. Okay, so C is the answer. Okay, C is the answer. Okay, simple question.